This is the very first video on time value of money. So we're going to derive some simple formulas that we use to solve these problems, and we'll work through some examples. Time value is one of the fundamental concepts in finance. It's a very important concept, and you're going to have to deal with it whether you study finance or not. If you ever borrow money, if you ever save money, if you ever invest money, then you'll be dealing with the time value of money. It's just the idea that if you can earn interest on your money, the value of that money changes over time, and that leads to some mathematical relationships that are important to us in the study of finance, so we're going to look at those. All right, it is a very simple concept. Said if you can earn interest on your deposits, if you can earn a positive rate of interest in the economy, then you'll have more money in the future, right, based on money deposited today. So we've got an example here. If you put $100 in a bank today and it pays you 5% interest on your deposits, well then all of you could do in your head, you'd say, okay, well, if I earn 5% a year on $100, at the end of the year I'll have $105, right? And that's a very simple illustration of the time value of money. By doing nothing but leaving the money in the bank for a period of time, it changes in value. All right. Now, we do this over and over again in finance. So we write the equations out and we try to write them in a way that's very efficient. So, when you do it in your head, you're solving this equation here. You're taking the $100 you started with, and then you add 5% of that $100 to the amount you started with, and you end up with $105. All right, we do this a lot in finance. We try to write the formula as efficiently as we can. And so we factor out 100 here, and we write it this way. 100 times 1 plus 5% equals 105. Right? It's the same math. It's just this is a more efficient way to write it. Okay, and then we say, okay, well, suppose we leave it in there for 2 years. Right? Now, the quick answer would say, oh, well, if I leave it in there for 2 years, I'll have $110. Earning 5% a year. But that ignores the fact that at the end of the first year, you'll have more than $100 in there. And so in the second year, you'll be earning interest on $105. And this is where we call this compound interest. Your interest starts earning interest. Right? So you actually end up with a little more than you might expect, okay, if you just at first thought. Okay, so we can write it this way. We know at the end of 1 year, we'll have 100 times 1 plus 5%, it's 105. We'll leave that 105 in the bank for the next year, and it will earn 5% interest. So that times 1 plus 5%. And that's 110.25, right? And the extra 25 cents there is 5% of the $5 in interest that you earned. All right, your interest is earning interest, and so you have a little more. Okay, and again, we're going to try to write this as efficiently as possible. So we can write the equation this way. We can say, well, we know this first 105 is 100 times 1 plus 5%. And then we're going to leave that in the bank and multiply it times 1 plus 5%. And so we could write it that way. But if we have 1 plus 5% times 1 plus 5%, well, that's 1 plus 5% squared. Right? So this is the most efficient way to write that. So we write the formula this way, right? And what I've gone through that example to show you how where the future value formula comes from. We've derived the future value formula, right? And we use this notation over and over in finance, so you should get used to it. Money today we call present value, and we write it as PV, right? Meaning how much money we have at present. We use R to represent the rate of interest. Actually, we often use I, and those are interchangeable. So it kind of just depends on what textbook you're dealing with. Very, very often we use R to represent the rate of interest. Sometimes you'll see it as I. Okay. We use T to represent the time deposited. Again, sometimes that is written as N. So it's the same idea there, the time that money stays in the bank and earns interest. Future value, meaning how much money we end up with in the future, is written as FV. All right, so if we put those in, we come up with this formula. Future value, the amount of money we'll have in the future, is how much money we deposit today, the present value, times 1 plus the rate of interest we earn. And then this is to the t power. That's an exponent there, right? To the t power. Okay, and that's our future value equation. Okay, so here's an example. I'm saying you've got $17,400 today. You're hoping to have $30,000 in 5 years. You want to know how much you'll have if you deposit that amount of money today and earn 8% a year and leave it in there for 5 years. Well, just plugging that into our formula. The present value is $17,400. The interest rate's 8%, and it's to the 5th power because we're going to leave it in there for 5 years. And that says if we deposit that much today, leave it in there for 5 years, we'll have $25,566.31 5 years from now. Okay, it's a very simple application there of the future value formula. Okay, here's one for you to practice. I even have the formula here, so I encourage you to pause the video and just try to figure this one out. You put $100 in the bank, you're going to earn 5% a year for 3 years. How much will you have in 3 years? So give that a shot. There's the formula. I'll mention here that the simple solution is included. Right? If you didn't know anything about finance and you were trying to solve this problem, you would probably guess A. Say, oh, well, 5% a year on $100, that's $5 per year, and I'll have $115 after 3 years. But that ignores the fact that as you go through time, the interest you earn will also earn interest. So that doesn't include the compounded interest. So to find the compounded interest, we're going to use our formula here, the $100 times 1 plus 5% to the 3rd power. And the answer here is D, 115.76. Okay, here's another one. Just encourage you to pause the video and practice this one. You're going to put $930 in the bank today, earn 7.5% interest for 6 years. So by now you should remember the formula. You can plug that in, see if you get one of the answers here. And there's the answer there, just using our formula. The answer is B. Okay, so that is the future value formula. Very, very simple formula to use. Now, we also turn this around and talk about present value. I've got it here as I think of it as the other side of future value. Instead of saying, well, I'm going to put some money in the bank today, how much will I have in the future? I say, well, I know how much I want to have in the future. How much would I have to put in the bank today to get there? Right, and that's called solving for the present value, okay, the amount of money you put in the bank today. So in a previous example, I said we were hoping to end up with $30,000 in 5 years. We can earn 8% a year. So the question is, well, how much would I have to put in the bank today? Earning 8% a year to end up with $30,000 5 years from now. And we can use our future value formula. The thing is, in this case, though, now we know the future value, and what we want to solve for is the money we need to deposit today. Remember, that's called the present value. Okay, so we're solving for the present value. Right, and then just simple algebra here. You can see to solve for this equation, you would just divide both sides by 1 plus 8% to the 5th. So we can say, okay, the present value, the amount of money I'd have to deposit today, is equal to the future value I want, divided by 1 plus the interest rate to the power of t, how long we're going to leave it in the bank. Right, and if I do that math, that says I need to deposit $20,417.50, earning 8% a year, and I'll have $30,000 5 years from now. Okay, so that's solving for the present value. And that's the present value equation. And by the way, you guys are finance majors, you're just getting started here. You will use this over and over and over again in finance. All sorts of problems in finance deal with, well, what's the present value of that money today? Right, so it's something you should really just know right off the top of your head, all right, the present value formula here. And I say here, it should be obvious that we just took the future value formula and solved it for present value, right? We divided both sides by 1 plus r to the t. Okay, so that's how we get it. So the present value is equal to the future value, the money you expect in the future, divided by 1 plus the interest rate you earn to the t. T again is an exponent. Okay, so here's a question. Again, you can practice. I encourage encourage you to pause the video and see if you can get my answer, one of my answers here. So you want to have $950 4 years from now. You can earn 9% on your savings. How much would you have to put in the bank today? All right, so again, very simple application. The future value in this case is $950. That's how much we want to have in the future. We can earn 9%. We're going to leave it in there for 4 years. If we do this math, we end up with $673. All right, so if I deposited $673 in the bank today, earn 9% interest per year for 4 years in a row, I would have $950 at the end of 4 years. Okay, I'll mention here, these formulas are for what we call lump sum problems. They are the easiest problems in finance. That's why we start with them. And there's only a single cash flow, right? Meaning, either you're putting some money in the bank today and then you're doing nothing else but waiting to see what it's going to be worth in the future. Okay, that's figuring out future value problems. I'm going to deposit some money today. How much will it be worth in the future? Okay, so I just make a single deposit today and leave it alone. Or I'm trying to figure out, I know I want to end up with this much money in the future. What single deposit would I have to make today to get there? Okay, and that's a lump sum. There's only a single deposit made. All right. Now, we will make these more complicated very soon by adding more payments. That is, instead of making a single deposit, I'll say, I'm going to deposit a certain amount every year. How much will I end up with? All right, that's not a lump sum problem anymore. Okay, but if you just make a single deposit, it's a lump sum, and the formulas we just went through will apply. Okay, now there's one more concept we can use with these simple lump sum formulas, and that's the rate of return. So if you invest some money in something to start with, and then after some time period you end up with a certain amount of money, you can calculate what your rate of return is on that investment. Right? And what we're doing here is we're just solving this formula for R. And so I go through a little bit of the algebra over here, how you solve that formula for R, but you end up with this expression here. The rate of return is the future value divided by the present value, right, that quantity raised to the 1 over t power, and then subtract 1. And that'll give you the rate of return. The technical rate for this is called the annualized rate of return. It means the average annual return you would earn on that investment. Okay, I've got an example here. You buy one share for $55, and then 4 years later you sell it for $95. Right, so you invested $55, and after 4 years you ended up with $95. What's your annualized rate of return on this investment? Well, in this case, what you ended up with was you ended up with 95. That's your future value. What you put in at the beginning was 55. That's the present value. T in this case is 4, so it's going to be to the 1 over 4 power, and then subtract 1. So if you do that math, I encourage you to pause the video and see if you get one of my answers here. And if you do that math, you'll end up with C, 14.64%. Okay, that's the annualized rate of return. And what that means is that this investment is the same as if you had deposited that $55 in the bank and earned 14.64% per year for 4 years in a row. That's what the annualized rate of return tells you. And I've worked that out here, showing you that, if you deposit that in the bank and you earn 14.64% per year, then this is how much you'd have at the end of each year. And notice after 4 years you'll have $95. Right? That's what the annualized rate of return tells you. Okay, I've got some practice problems here. I encourage you to pause the video, work through these on your own. So this is a problem where you want to have $55,000 in 3 years. You can earn 7% on deposits. How much do you need to deposit today? So that is a present value problem. We can use our present value formula and solve that. So take the amount of money I want to have in the future, divide by 1 plus R to the T, and there's the answer. Okay. here's another question where you deposit this amount of money in the bank today and you want to know how much will you have in 3 years. So it's asking you for the future value. You know the present value, how much you're putting in the bank today. What's the future value going to be, so we can use our formula. Again, I encourage you to pause the video and work that on your own. And I've got the numbers right there. If you remember from the previous slide, this is just kind of the reverse of that problem. I'm just showing you that if you deposit that amount of money in the bank today, earn 7% for 3 years, you'll end up with $55,000. Okay, and then here's a rate of return problem. So at the beginning you invested $35 into this stock. 5 years later you sold the stock for $102. What's your annualized rate of return? So remember, this one we're solving for R in our lump sum formula. And if you do that math, the future value is 102, the present value is 35, the time is 5, so it's to the 1/5 power. If you go through that math, you'll end up with 23.85%. Okay, so that's an introduction to time value with the lump sum formulas.